Welcome. Now we're going to talk about making a linear regression. We're going to use our graphing calculator to find a linear regression. And the idea behind a linear regression is that you may be given data over here on this PDF that you can see here. We have years and then gross domestic product in trillions. And what you can see is that over years, as time passes from 1980 to 2010, that period from 0 to 30 years, the gross domestic product increases from 2.8, and this is measured in trillions, to 14.7. And the idea is that we can take this data and create a scatter plot. And then we're going to use our calculator to find a line that best models the data. So before we can do anything, our first step, and you only have to do this once, is we're going to go ahead and turn the diagnostic on, which will give us our correlation coefficient. So the first thing you want to do is press second, and then you press 0 to get to catalog. You'll notice it says catalog in small blue above the 0 button. Now we want to scroll down, but to save us some scrolling time, I'm going to hit the button with a D above it, which is the X to the -1 over here on the left. And then I only have to scroll down about 10 times. Now you'll notice there's a diagnostic off and a diagnostic on. You want to make sure that you're choosing diagnostic on. So I'm just going to hit enter. That puts it on the screen. I hit enter once more, and I've turned that on. And that's going to give us what's called the correlation coefficient. The next thing we want to do is we want to enter our data. So when we're dealing with statistical data, we're going to be using the stat button. Stat. So we hit stat and we have options: edit, calculate, and tests. The first thing we want to do is edit that data and input it into our calculator. So I'm going to hit enter to edit. I'm going to enter my X values in L1 and my Y values in L2. You do not want to delete these columns. You can clear the columns, but don't delete them. You need that L1 and L2 up there at the top. So I'm going to enter my data carefully. And if I come over here, I think I can zoom in a little bit, make that a little bigger for us. I don't know what I'm doing. Here we go. So you guys can see it a little better. Make this guy go away. There we go. All right, so I'm going to enter over here on my calculator 0, enter 5, 10. And you want to make sure that you enter everything correctly, because if you make one mistake, your problem is not going to work out properly. So 25, we got 0, 5, 10, 15, 20, 25. I need 30. So double checking. And I'll do the same for my L2. So those are my Y values: 2.8, 4.2, 5.8, 7.4, 10. I don't need to put 0.0. 12.6 and 14.7. Make sure you hit enter. You need the same amount of entries in both L1 and L2. So that's what this next step here is detailing. What it was saying that we did is we just needed to enter the data. So I hit stat and I chose enter to edit this data. I put my X values in L1 and my Y values in L2. So once I have that data in there, now we can calculate the linear regression. And I'm going to actually do some optional steps first. So you don't have to do these steps, but it can be helpful when you're trying to figure out what's going on. So the first thing we want to do is maybe view this scatter plot. Now, we have a nice graphing calculator, and it's not showing on there right now. Well, we need the stat plot turned on. So I'll hit second and then Y equals. And I'm going to hit enter beside plot 1, enter once more to turn that on. Now, we don't need to change any of these other settings. Essentially, this is saying it's going to make a scatter plot. It's not going to connect them. We don't want that. We don't want a histogram or box and whisker graph, modified box and whisker, or step graph. We don't want any of those. We just want this scatter plot. The X's are coming from L1, the Y values are coming from L2. It's going to mark them with blue squares. So I've turned it on, and I'll just go back to my Y equals. You'll notice under Y equals, plot 1 is highlighted. Now I could go up, and that's a quick way to turn it on. Just go up there and hit enter. So I want to hit enter, so my plot 1 is on, and now I'm going to hit graph. And I see my data, but I don't see all of the data. So we want to zoom. A special way to zoom is to hit zoom 9, which is zoom stat, and that puts our data on the screen. And what you can see here is this data, even though it's not a perfectly straight line, it is modeling a line. And what we're going to do is we're going to use the calculator to determine what that line would be. And once we know that line, which is a really good estimate of what we're looking at, then we can use that line, that model that we've created, the function that we created. It's a linear function in this situation because we only know how to deal with lines right now, but we can use that to predict for the future. So I've got my scatter plot. I see that right here on the screen. I'm going to go back to stat, and now I want to calculate. So I've gone to step 3. I'm going to calculate my linear regression. Linear regression is either option 4 or option 8. It just switches AX plus B versus A plus BX. You do not want to choose LN regression. That's a natural log regression. So I'm just going to choose option 4. And I'm going to hit enter. My X's are coming from L1. My Y values are coming from L2. It gives you an option to store your regression equation. So I could say, hey, whatever this equation is that we calculate, I want to make sure this gets stuck into my Y equals. So you do have that option. If you hit vars, this vars button, you can arrow over just once to Y variables. And I'm going to choose Y1. So that's just going to kind of automatically plug it in for me. So I don't have to plug and chug. I don't have to write on my paper and then transfer it to the Y equals. And it's also going to give me a lot of decimal places when it does that. So going all the way down to the bottom, we hit enter. This is my Y equals. So you'll notice I have R here. R is my correlation coefficient. All right, and that tells me how good my fit is, how well my model works. So my Y value is exactly 0.405, and my B is 2.1392. So you'll see that over here, that if I was writing that on my paper, I might round that value. All right, so 2.139 and just truncate that. So we both have 3 decimal places. So that's my Y equals equation. And now I'm going to go and look. So you'll notice I've already saved that in there, 0.405x plus 2.139. And then it's giving me all those extra decimal places, which you can have or you don't have. It just depends on how you've worked through the problem. At this point, I'll hit graph, and you see that line that the calculator found is the line of best fit for all of this data. Okay, so that is my linear model, and I could use this linear model to predict. The correlation coefficient here, 0.99. We want to think about the correlation coefficient as like a percentage or a grade. So this is like saying 99.3%. So if the question asks you how confident you are in using this model to predict future information, in this situation, because we've got 99.3% correct, we would say, I feel really good that this model or this function models this data in a linear fashion, and I could use this function to predict. So if I asked you, what is the gross domestic product in 2020, that would be 40 years later, we would plug 40 into the equation, and I'm going to use my table to do that. I'm going to go to my table. I'll actually set my table so that it asks for my independent variable x. So we're going to ask for x. I'll go back to my table. I can type in 40, And in 40 years after 1980 or 2020, the gross domestic product measured in trillions of dollars, we would estimate that to be 18.339 trillions of dollars. So that's how we can use our calculator to find a linear regression. I have one last thing for you. I will encourage you, especially if you're not going to be doing this a lot, to go on up here and turn your plot one off. That's going to potentially cause an error, because if your calculator is trying to graph, some data down on the screen over in one corner, and then the line doesn't fit on the screen and it won't be able to do that, it's going to give you an error and you won't be able to see your graph. And that's a really common problem I see. So go ahead and turn that plot one off, and that's going to turn, if you notice I go back to my graph, it turned the scatter plot off. So I'm just graphing the function. So I hope that helps. Let me know if you have any questions.